Welcome to my YouTube channel. So in this video we will look at a concept of geometric progression. We have been on sequence and series, right? So by definition, if you have a sequence where there is no zero elements, now this means that in geometric progression we don't have a zero as a term. Okay, and you would see the reason because we have what we call common ratio. So if you have a sequence where there is non-zero term, and if the ratio of any term is and its preceding term is always constant, then the sequence is a geometric progression. So what are we saying? That if you have a sequence, for example, this is a sequence and there is no zero here. You know, in arithmetic progression you can have zero. So there is no zero here. And if you pick any term here, for instance, if I pick this guy now and divide it by the preceding, which is 1, so you will see that I'm going to get 3/1, which is 3. And if I pick this one, 9 divided by 3, I'll get 3. 27 divided by 9, I'll get 3. And you know, whenever you pick a term and then divide it by its preceding term, you are getting the same ratio in that sequence. So you call that sequence a geometric progression, which we can also call exponential sequence. So look at this other one, 1/4 divided by 1/2, and you will get 1/2. Okay, just the same thing will happen here. Look at here, if you divide this by this, you get 4. Divide this by this, you get 4. So any sequence of this nature is called a geometric progression, and that constant ratio that you get when you divide a term by its preceding term is called a common ratio, represented with letter R. Okay, so these are the examples we have. So from what I said here, our A here is 1, and our common ratio here is 3. And our A here is 1/2. Our common ratio here is half. While our A here is 3 and our common ratio here is what? 4. Okay, so that means our common ratio is actually what you use to multiply a term to get the next term. Okay, so if I use 3 to multiply 1, I'll get 3 times 3, 9, and so on. Okay, so now the next thing we'll talk about is the nth term of a GP. In AP, we talked about nth term, and so we're going to see that here also. Okay, so now you would see that, like I said, in a GP, you have the first term, which is T1, your A, being equal to A, and the second term is actually equal to A times the common ratio, and the third term is equal to A times the common ratio, the second term times common ratio, and that's going to give you AR squared. So, and you see that the fourth term will be AR raised to power 3. So if you keep going down, you will see that your Tn, which is the nth term, is actually equal to A times R raised to power. From here, you can see how the order is going. This is power 1, this is power 0. So the power of your R is always 1 less than the number of the term. So since we are in fourth term, the power of R is 1 less than it, which is 3. Therefore, for any nth term, it will be A times R raised to power n minus 1. And that is the formula for calculating the nth term of any geometric progression. All right, and so we'll see some examples. All right, so example 1 says we should find the 20th term of the sequence 4, 8, 16. And so now always recall to write your formula. Tn is equal to ARn minus 1. So here we need about 3 things. The A, where our A is equal to 4, and our n is 20, which is the 20th term. Now what is our R? Remember we said R is just pick any term divided by the preceding, and so our R here is 2. So this means that our Tn is equal to A, which is 4, times R, which is 2 raised to power of n, which is 20 minus 1. So that's going to give you 4 times 2 raised to the power of 19. And then if you multiply this, that will give you the solution to this problem. Right, so we look at the second example. Right, so the second example says that sixth term of a GP is 2000, and then we should find the first term if the common ratio is 10. Okay, so that means our T6 is equal to AR raised to power 5. That's 6 minus 1. And then this T6 is giving us 2000 equal to A, which is what we are looking for, multiplied by 10 raised to power 5, which is the common difference. And so that means if you divide both sides by 10 raised to power 5, you should get 2000 all over 10 raised to power 5. And 10 raised to power 5 is 100,000. So take away this. So we have 2 all over 100, and that is 1 over 50 as the first term of the sequence. Right, so the third example here says that the fifth term of a GP is 18. That means T5 is 18, and our T5 is AR raised to power 4. When you subtract 1 is equal to 18, while the third term, is 2. Third term, which is T3, and that is equal to AR raised to power 2, is equal to 2. And they're asking us to find the common ratio and then the first term. So what do we do with this? So since you are in a geometric sequence, if it was arithmetic progression, you just do maybe a subtraction to solve, because you are going to solve this simultaneously. So but now we are in a GP, we are going to divide. So we divide equation 1 by equation 2. So if you do that division, you are going to have AR raised to power 4 all over AR raised to power 2 is equal to 18 over 2. So you're dividing both sides. And so if you do that here, our A will go away. So 2 here will cancel 2. And so we're going to have R squared is equal to 9. Therefore, our R alone is equal to the square root of 9, which is equal to 3. And that's the solution for I. And then to do the they said we should find the first term. So you can substitute R into any of this. And I want to substitute it into equation 2. Equation 2 says that AR squared is equal to 2. And so my A alone will be 2 all over R squared, which is equal to 2 all over 3 squared. And so therefore my A is 2 over 9. And that's the solution. Okay, and this is where we're going to stop for this video. Please kindly subscribe to our YouTube channel, like, share, comment on our YouTube videos, and we'll see you in our next video. Bye.